In this video, we're going to prove some properties of transpose matrices, namely these four right here. So how about we get right into it? If you take the transpose of matrix A, that means you interchange the rows and the columns. But then if you take the transpose of that, if you again reverse the rows and the columns, then you're going to get back to your original matrix. So let's look at this. A transpose, or the ijth element, the ijth entry of a transpose is the aij entry of a transpose, but that becomes aji. Okay, that becomes aji. But now, if we transpose again, we get back aij, which is the ij's element or entry. Let me use the same phrase, entry of A. Hence, A transpose is in fact A. How about we try the next one? A plus B, well, that's A plus the ijth element. Keep forgetting to write that. The ij's entry of A plus B is A plus B ij. Which is equal to aij plus let me say that first. It is going to equal to their aij entry plus the bij entry. Now, if I take the transpose, but before I do that, that's the same as our A plus B ij. Now, if I take the transpose of this, what I get back is A plus B, the ji entry. But this is the same as aji entry plus the bj sub I entry. But this here is the same as aij transpose. And this entry here is the same as bij, but the transpose. And this is equal to the ij's entry of A transpose plus B transpose. Okay, so we got the first two. Now we need to look at the third one. This one, of course, is going to be the harder one. We want to show that AB transpose is equal to this. Well, the ij's entry of AB is aij, is equal to A times B, ij. But let's see. This is nothing more than the summation of aik bkj as k goes from 1 to n. Okay, we'll assume it's an n by n. Okay. Now, we want the transpose. We want the transpose. So this is equal to the summation as k goes from 1 to n, and we interchange I and j. A jk bki. But this is the same as, this is just a product of two real numbers. They commute. So this is the same as bki times so drop trickier than I thought. And yeah, I'll still write what I was going to write. It's bki times ajk. K goes from 1 to n. Now I'm going to switch the I into k. So I get bik. But I better say transpose. And I'm going to switch the j into k. So I get akj. Transpose. But this is equal to the ij's entry of B transpose A transpose. Hence, AB transpose is B transpose A transpose. Okay, now we want to prove the last one. Let me just write it down here. We want to prove that R times A transpose is equal to R times A transpose. And here's the proof. So R times A, the ij's element of it, the ij's entry of RA is equal to R times AIJ. But that's R times AIJ. And now, if we take the transpose, that means I interchange I and J. So this is R times AJI. And then we're done. This is equal to the ijth entry of R times A transpose. That completes this video. Watch and learn.